you can use that as well. So let's kick it all off. It looks like Ron is almost ready. Are you ready, Ron? Ready to go? Ladies and gentlemen, give a warm welcome to Ron.
Okay. Thanks, everyone. Thanks for coming. Thanks, David. Without David, obviously, we can't have this room, and this conference will not happen, okay? So thanks, everyone, for coming, and thanks to Microsoft. Okay. Hold on. Let me mute this thing. Or this one. Okay.
Just try Windows P and see if it is too close. Just make sure you're either duplicating or extending. And you're not, so go down to either duplicate or extend, whichever one you want. Remember, it should also appear there. Okay, the other possibility is
Hello, hello, hello. Hey, I think finally we are ready to start. Okay. Sorry about all the troubles and losing a few minutes. Cutting back into my time, looks like. So I'm going to extend it a little more, and I'll keep everyone waiting for the panel. How about that? Okay. So let's. Oh, this is extending. Okay. So I need to look at this one. Okay, there we go. I'll do a quick introduction. This is the agenda for today. So we have an executive panel. Shefali, Nitin, and Karen, they're all here. Shama couldn't join us today for the Polsky. Polsky will be represented by Rahul over there. And we have a few, two startups actually from Polsky. I'm looking forward to seeing what they're doing. One on healthcare, the other one on quantum. Very excited to have them over. And there's me. So I'll bore you for a little bit, okay? And then this is about some of the members who have been helping. Obviously, this wouldn't have been possible without the help of all these guys. David Gerard, he's here somewhere. He's sitting over there. He fixed the screens, and also my friend Harry over here. I don't see Mary. Paul Dittman, who was organizing the whole executive panel. So without Paul, we couldn't have done it. And of course, without AI Alliance and Dave Nielsen, who's sponsoring our pizzas and all the food and drinks. So thanks to all these guys, and let's get started. A little bit about the event itself. So the events are now being posted at the AI Alliance site, as well as the AITP site, and of course you can check it out on researchnet.ai as well. Okay, that looks like my presentation, so I'm going to switch over. And as always, I'll give you a little bit of update on what we're up to, and then so I have to drag it to the other screen, right, David? Yep. Hold on. Okay, there we go. And that's me again. Okay, let's move on. Again, me. You can read about me all the time. Okay, so let's introduce to you what Open Development Platform is. This is something that I have been collaborating ever since my IBM Center for Advanced Studies days. I used to head Center for Advanced Studies there. So that's our collaboration with all the universities around the world. I have a bunch of students. I think at this moment, 150 plus students actually in this program. So if someone is interested, let me know. We're always eager to expand on what we're trying to do some research in open source, MIT license, and so that's the Open Development Platform itself. However, so what is AI Alliance? AI Alliance was started by IBM, and Joe was supposed to be here. I didn't see Joe from the Alliance. Anyway, so I'm also part of the Alliance. Open Development is part of the Alliance. Over here, NYU, a lot of universities and other organizations are there. Now we are up to 100 plus organizations. We are all trying to collaborate on AI and try to see how we can help each other and make some progress. What is IBM Center for Advanced Studies? We had many centers all around the world. I just put few centers in North America. So we were collaborating with lots of universities around the world and trying to see, before I left IBM, now I'm doing the same thing outside of IBM. So anyways, here's some of the things that we are trying to do. I've presented this a couple of times now. So what is the platform? We are trying to build an automation platform which can have agentic frameworks, or you can integrate with other agentic frameworks. I'll get into a little more details in a little bit. And then what we're trying to do is connect to the research. We're trying to see if we can understand research papers and SRS documents and things like that, and convert them into code at some point. So there's, I'll go over that a little bit. And then support and services. So you cannot run anything without support and services. Okay, so what is the problem? The problem is there's not enough resources to do the job. You need automation, you need observability, you need stable code to go into production, or else, I mean, you can't just rely on something that's generated. You have to check it, you have to test it, you have to go through the whole life cycle. So that is our goal, and how can we automate that? Some of it through AI, some of it through traditional pattern engineering processes, which was invented not by me, all the way back by the three amigos, UML and case tooling and all that stuff. So I have my own pattern engine, which is at the base of all this stuff. That's how we can generate all this. So what is our goal? Our goal is to create not just code, but code which is actually optimized and highly, highly productive, and we can put it into production. So that is the whole goal, and how can we manage the life cycle of that? So that is the goal of the whole platform. And so what I say in general is it's an automation platform to build other products on top of it. And we will be building some of the products. I'll mention a couple. So this is our biggest use case. Getting, say, research documents from Archive or anywhere else, Springer or wherever. Archive is the best way because you have a lot of, everything is free, right? So you can download a bunch of things, you can try things out. And we want to do all the stuff, end-to-end pipeline, as open source, and that can be run locally. So yes, you can connect to any other GPT or whatever models you prefer, but we want to run everything locally. It should be runnable locally. And then, of course, if you want models that are hosted by other organizations, yes, we can do that. I've gone through this in other of my presentations as well. This is the pyramid I consider as the code maturity pyramid. So you have chaotic code, and then eventually you go up to the level of best practices. And then when you have very good code, that's when you patternize. That's where we come in at the very top. When we want to patternize actually workable code that is in production, production-ready code, that you patternize, and then you can replicate that. Now, how do you understand that is the question. So the solution is very simple. Well, I wouldn't say it's that simple, but yes, our solution is basically what we are trying to do is do all this stuff, and at the bottom of all of this is the pattern engine, right? So it's our patented technology. It's a pattern engine which is hierarchical in nature, which lets us do all this stuff. Okay, I'm just racing through it because of time. If you have any questions, of course, ask me afterwards. So what is at the base of all this is the Vortex pattern engine, which I was referring to. This has nothing to do with AI. This is everything to do with traditional deterministic codes. Okay, generation of code, very, very traditionally what we used to do. Now, to connect to this pattern engine, we have something what we call deterministic NLP generation. So when you're putting in specifications in a very structured manner, that is not basically what we mean by NLP. If you put things in normal text, like in documents or something else, or you just chat with the system, that is what we're calling natural language. And that we are basically mapping into the engine, so we have deterministic output from the indeterministic statements that are being made on the document. So that is the distinguishing factor. And we are doing some deep NLU research. This is still underway. Hopefully, next year, we'll get to a position where we can actually demonstrate this and go through the whole pipeline and generate some code from the research document. So we are still working on it. Okay. So this is, you'll see on our website, this is the biggest use case we are dealing with. Get the archive documents or SRS documents, go through all this pipeline. Eventually, we want to generate two types of things. One is create the entity relationship model, which creates your database and all that stuff, very, very structured. And then when we create the CRUD model, all the way to the UX. So rather than just generating UX, we're going the other way, creating a very, very solid structure in the database and then building it up to the UX, okay? And the other side of it is basically dealing with process flows. So can we engineer process flows automatically from these documents? That's the other thing. Then we have task automations, and that's where our agentic framework comes in. I'll give you a little more details about the agentic framework. We are basically using Google's ADK, and that has becoming the standard. I wouldn't say it's the full standard, but anyways, but this is also a little bit dependent on LLMs. We don't want to be dependent on LLM. To me, an agent has three things. One, it has to communicate with some AI model. That's why we're calling it AI agent. The second thing is it has to be able to call some tools, whether we use MCP or some other tools. MCP, people are losing faith a little bit on MCP. Towards the beginning of the year, when it came out, I had more faith in it than now. I always had some problems because it's indeterministic, again, what you call. I like deterministic calls. So, so that's another thing we're looking at. And then how can we improve the process over a period of time with human interactions and things like that, okay? Okay, so there's three parts to it, and I'll actually show you some of the code that we are developing. So there's three things that we usually refer to and never get into details. So this time I thought I'll show you some of the internals of what we're doing, okay? So this accelerated asset pattern, what is it? It is basically implementation of the standards that we've put forward. The standards are basically XSD files, very, very structured, very, very specific to whatever we are trying to do and whatever we are trying to generate or we want to integrate with. So that's that, and this is the implementation of that. And this inherently has the pattern engine as well as the process orchestrator built into it. So that's why we can do all this stuff. Okay. Reusable asset patterns. This is at the very top of after we have architect the best practices. Then we, hi Kasi. Kasi is standing in the back. Hello. So anyways, so a little bit of distraction. So these are at the epic of what you've already tested and codified, and you're actually wanting to patternize, right? Not just any code. Okay. Hopefully this moves. Okay, one thing, this is absolutely new, this slide. So we have put together, so we have been implementing this for a few products now. I'll mention a few of the products that we have started implementing using the framework. This is something that we published. We'll give you a little live demo. Whenever you see the sign on my slides, there'll be a live demo. So we have integrated, except for Kafka, we haven't put in Kafka yet. But other than that, we can monitor all these products that gets created, not just standalones, but we can monitor them through the Grafana Prometheus using open telemetry. Okay? Okay, so Diptam, my chief developer, he's in Kolkata, India. He's standing by, so he wants to show you how we are doing this. So Diptam, are you still there? Hold on. Let me try to see if we can get the, this has always been a problem through Zoom to switch over the speaker. Hello, Diptam, can you hear me? Diptam, can you hear me?
Hey, Ron. Yeah, I can hear you.
Can can take it over. Diptam, you can take over from now. You want to share your screen and go and do a quick demo of the monitoring stuff? Of course, we can't hear him now. Diptam?
Hello?
Yes, we can hear you.
Okay. So, hey everyone. This is the ResearchNet managed services based on Grafana and OpenTelemetry. This is how we are currently tracking the live ResearchNet.ai website. This is all live data. As you can see, we're tracking the side load time, the view count, and some buttons. So this is updating in real time. As you will visit the website, this data will update, and this using this data, so the button clicks or views or the side load time, we can actually track the site health, how users are interacting with the site, and a lot more.
Hold on. Hold on. Diptam, you can start again.
Okay, so I'll start from the beginning. This is the live dashboard of ResearchNet managed services. And this is exactly the dashboard where we monitor our hosted ResearchNet.ai site. So this is all real-time data. As people visit our ResearchNet.ai site, this data automatically gets tracked over here. We track the side load time, the views, and some button clicks because that's the most important data for us at this moment. But this can be expanded with while tracking the user interaction, how people are interacting, in which page or which section people are spending more time. Overall, this can be an alternative, a better alternative of Google Analytics, because we can actually know exactly how the sites are loading, where the system is lagging, which buttons are getting the most click, and how many views are there. At the same time, we don't have to depend on another service to just track this. Everything can be done through hotel. That will also reduce the overhead of that site. Now, this is just the dashboard for the ResearchNet.ai. In real world, people will have multiple services. So for that, this service also supports a single pane where you can have multiple services in a pane and you can just track them. So this is a simulated environment where we are getting the ResearchNet AI data in real time, but some backend services are getting simulated using my computer. So as you can see, we are tracking the Java request duration count, the Node.js 99th percentile delay, and some more data. These are the metrics that we are getting in real time. Then also we have the logs. So all the logs from all the relevant services are getting logged. We can have a quick look and see which service is having error or which service is having some problem. You don't have to guess work. You can just look at the data and do your relevant work. Creating new or adding new sources is also easy. You just have to come to the explore page from here, and you can select which type of data you want to track. Prometheus will track all the metrics. Loki will track all the logs. Tempo will track all the traces. So say I want to track Prometheus. Over here, I can just filter through service name, and I can select any service. Say rnet site, that's the live data, and I can run the query. In real time, this will give me all the data. I can filter more. I can select the metric that I want to track specifically. And after I'm done with this, I can just click on this add button, add to dashboard, create a new dashboard, or add to an existing dashboard. And say I want to add to this new dashboard. You can open the dashboard, it will open in real time, and then I can edit, rename it, say new name. I can change the type of data I want, so I can choose between time series or maybe bar chart. Time series is more relevant in this case. Then save the dashboard and done. Okay, and we're good to go. Can resize, and everything is done in real time, and it's a single pane of glass. Can track everything. Over to you, Ron.
Let me switch over. Hello? Okay, we're back here. Back to Chicago. Okay, so this should be a little bit easier now. Okay, so let's share the screen again. This presentation is here, that's over there. That's why I usually like doing the duplicate. Okay. Yeah, how do I put it on the other side? Yes, that's the one. Yeah. Okay.
There you go.
Awesome. Yeah. Let's start off again. Okay. Yes. Hello. Okay, so we are back. Okay, so let's move on from this. Harry? Yeah, next. Okay, so this is another example that we did recently. So this is basically document automation. You can enter all kinds of data in an Excel sheet. That can be patternized. It can be mapped through some of our standards that I was showing you. It's called DocH, Document Handler Standard. So that can be transformed into our data processor, and then that gets automatically indexed in in-memory database. And then from that, you can do all kinds of queries and all that stuff. And then eventually, you can update presentations or documents or things like that. So if someone is interested in using this framework, let us know. This is, again, based on all the pattern engineering. And we actually implemented it for Robintroft, and we talked about it the previous time also. So we'll move on. Okay, so this is, again, nothing new. We talked about it before. So this is our agentic framework, basically. So you can route all the way down to, if you want to call a MCP tool, call a model. It can be any model, do some inference, do some collection, send it out, right? And this can be any sort of framework. So say you have already invested in, say, Crew AI or NA10, we can actually generate the code from this framework to be used in NA10, or we can integrate with NA10. So some parts work in this process engine, some parts work on NA10 or something like that. So this makes it very, very flexible and useful. Okay. So, okay, this is something that I was telling you about, all the specifications. So we will be publishing towards the end of this year all the specifications, and then we can have others contributing to these specifications as well. Okay? And that's our team. Abid and Sanjay, they're not here today. So Abid is also a professor at Northwestern and University of Chicago. Sanjay is in India. He's managing all our Indian contacts and all that stuff. Let's move on. Want to credit our team, starting with my friend Andreas. Andreas is the CAS leader for Mexico. He lives in Guadalajara. Misbah was supposed to be here. I don't see it. Oh, Misbah's here. Okay, there we go. Misbah's here. That's Diptam, who was giving the demo from India. We always have a little bit of delay going there. Vishnu is not here. He's one of my students from Illinois Tech. Oh, my son, he was supposed to be here. I don't know whether he disappeared. Oh, he's sitting in the back. Okay, there we go. Let's move on. And we are also starting a collaboration with Sunil. Sunil is new to our team, so he's going to be looking into all our artifacts and stuff. We have too many artifacts, then we have time to actually publish, so he's going to take care of that from now, getting into IEEE and Archive and all these places. So that's that, and last but not the least, Yash, who has been helping with the documentation and all that. Okay, one more project that I was mentioning. I guess it didn't move. Okay, this is the other project I was mentioning. So that's my friend Shantanu. He's from California. He used to work for NASA at one point. That's me and Daria, Abid, and Arvind. He's a professor from Sweden I was referring to when we were talking to some of the folks. So this is the project that I was referring to on psychology and how to gamify psychology to get information and then do studies. So we're looking forward, and we're actually another person I have not put here. I need more information. We started a collaboration with Kenji from the University of Japan. So next time we'll have Kenji in here and give you some updates on that as well. Okay, so that's Kaplan Center, Kaplan Institute. We are going to collaborate with them and give them our alpha code. And we have promised the same thing to Polsky. And Polsky is here, Rahul somewhere. Oh, I see you. Yes, and there's 2 cohorts, more than welcome to connect with me and use the alpha code to generate your products. Okay? Yeah, let's move on. This is our largest collaboration so far with a university. That's why I put it here. 120 students. I forgot to, I had the same typo in the previous presentation. So 24 projects actually, 25 professors, and yeah, so each project is basically headed by a professor, and there's a professor that's looking after the whole program. So that's that, and 10 mentors. Without the mentors, we can't do anything. Okay, so again, these are some of the presentations I did in the past. We can move on and to the end. All right. Yeah, thank you. And I'll share the slides with everyone, as will be shared for all our presentations and all that. So yeah, you don't have to take pictures. It will be made available on GitHub. Okay, thank you so much. If you have questions, I'm here. Thank you. And I think everyone's eagerly waiting for the panel. I see Karen there. Shefali, please come up. And Paul, you want to introduce the panel and our moderator? Oh, Nitin. Yes, sir.
Frank can introduce the other one.
Oh, there we go.
Hello. Our moderator today is going to be Frank Yannon. He's the BISO from the Bank of America, and he will introduce the panelists. Actually, he'll probably let them introduce themselves. Go ahead, Frank.
Okay. Hi, everybody. My name is Frank Yannon. I am with Bank of America and have the honor today to host an incredible panel. A little bit of snippet or background on me, first of all. So, long career in IT. Started out as a programmer, actually, and worked my way all the way up to a CIO. I was CIO at a privately held insurance company for about 8 years. And then about 10 years ago, as a CIO, or as if you guys all work in IT, as you know, you have to balance everything, the budget, all of the functions and features you're building, the timeline, the people, et cetera, and one of those aspects is obviously security. So about 10 years ago, I segued over and went deep in information security, and today I am what we call a business information security officer at Bank of America. The way to think about that is I'm kind of the front end, if you will, of the entire security program that we have, our global information security program. And so I face off with our CIOs and heads of lines of business areas, helping them address various dimensions of risk, essentially. So very happy to host the panel today. And before I get into the topic, which of course you guys know is about AI and the different dimensions of AI, we're blessed to have an incredible panel of CISOs, and I'll let everybody introduce themselves.
Thank you, Frank. Hi, everyone. I'm Karen Haberkas. I am both the CISO and the privacy officer for the University of Chicago Medicine Health System. I don't have quite a illustrious career as Frank does in IT. I actually started my career. Long. Okay. We're probably the same age. So before I became the CISO and privacy officer, I had an early career as a licensed clinical social worker. So I know a lot about behavioral types of things. That's sort of my forte in security and privacy. So I will turn it over to Shefali next.
Thank you, Karen. So Shefali Mukhencherry, CISO, Chief Information Security Officer, and Chief Privacy Officer for the University of Illinois Chicago, so UIC. And I've been there about 3 years. We're doing some great things over there. Prior to that, I've got 30 plus years of experience in cybersecurity, health policy. At one point in time, I used to negotiate managed care contracts for about $300 million for Lurie, long ago, for about 11 years. So master of many different fortes, but my true love is cybersecurity and privacy. Over to you, Nitin.
Thank you, Shefali, and good evening, everyone. I'm Nitin Raina. I'm the global CISO for ThoughtWorks. We are a global technology consulting, software design, engineering firm. I've been with ThoughtWorks for almost 15 years, plus a long stint. I've been in the industry for similar, maybe 28, 29 years. I've done a lot of work around, especially around IT, and did a lot of work on infrastructure and operations. And then I moved over into security in 2015. So being the CISO for ThoughtWorks for the last 3 years, but I also have enterprise risk, business continuity under my belt. And I'm in the operational leadership team of the company because, been there a long time, so very close to the business as well. Very happy to be here and would love to connect, network after the panel discussion.
Hot potato, right? Yeah. Okay, so the panel today will explore how AI is transforming information security. And, when I think about AI, and I'm curious if everybody else kind of feels this way, there's always developments in technology, right? We had to deal with the cloud, and we had to deal with DevOps and blockchain. What are we going to do about blockchain, et cetera? This, though, kind of feels different to me in the sense that I feel like it's been thrust upon us. And I remember kind of reading the first time about ChatGPT. I'm sure I was a late comer to it. It was like over Christmas break 2-3 years ago or whatever. And I was like, what the heck is this? And what, you know, and this is kind of cool. And of course, probably people here have been studying about it for a long time, but it was very new to me. And where on those other things, like migrating your program to the cloud or what have you, it seemed like you had time to put your program together and plan it out and prioritize things. And it feels to me that there's a lot of urgency. We're kind of chasing things. There's rapid adoption either by our line of business areas or our competitors that we have to address. There's governance that has to be put in place that we didn't have before, third-party use, and of course the adversarial aspect of things. So with this, there's a sense of urgency, and like a lot of things, it's a double-edged sword, right? It's powerful on both sides of the aisle. And so let's start out with the positive aspects of AI, and that is as a security enabler. So Nitin, I'll actually start out with you. How are you using AI to improve detection of early stage leaks, data exfiltration attempts, et cetera?
Thank you, Frank. Yeah, so I think there are a ton of experiments that most of us are doing, right, in this space. So the way we are looking at AI to help us in the domain of security is primarily if it is able to help us with faster triaging, if it is able to help us with with the analysis that can be done, and we can save time for our analysts so that they can do more meaningful work. So there is a lot of work that is happening where you know that if you look at EDR or you look at network, you look at cloud security, all of these are leveraging AI in their true model, right? So they are able to use AI natively, and we are able to leverage AI so that the previous issues that you used to see were mostly related to signature-based or rule-based alerts. Now the attacks are getting more sophisticated. So if we are able to leverage AI models, and if it's able to give us data, and it's like, hey, there is an intent here, or there is a pattern here, I think those are the things that are helping us to catch things early. And if we are able to catch it early, we can be more proactive in managing incidents.
And Nitin, I'll add that, what we're using AI for is helping us understand where our protected health information, so PHI is traversing, where's all the PII traversing, right? So we have a application tool that has AI built into it, and so it will help us, figure out, oh, you know what, that user is using PHI with AI. So we're using AI to track AI as well.
Let me stay with you for a moment. So AI-driven threat hunting, anomaly detection approaches, what tools are you using, and what kind of detection and resolution are you seeing?
Yeah, we'd all have to sign an NDA, I'm sorry. We'd have to do an NDA to tell you all that. But there are certain types of tools that we can use, right? So a data security posture management tool, a DSPM tool, that's one of the things that we use. I won't tell you which vendor, but that is something that you can use to understand where's your data going, who's using it. So like, everybody's got Microsoft. We are here. So Microsoft Purview is one of the tools that we will use to help us understand, where ChatGPT or any of their other Microsoft products have AI. Say, someone's storing PHI in OneDrive, right? We may be able to look and say, is this person oversharing their information? Or is there data leakage here, right? Because we can tie someone's access to certain files based on their employment status, right? So if they've been terminated a long time ago, why do they still show active as accessing a file? So you can use AI to aggregate data, correlate data, and then it's up to us as humans to trust it, right? So we want to verify it first, make sure we're seeing what we're seeing, and then correlate it, understand it, and then do what we can if a decision has to be made, right?
Karen, are you seeing any particular areas where AI is outperforming human analysis?
Yeah, I don't know if I would say outperforming, but more I don't want to repeat some of the things my peers have said because we're doing, I think, a lot alike. I think the concept thus far is around efficiency or trying to free up time so that staff can do things that are probably more critical and letting the AI find things that can save time. So, sort of the easy thing isn't sort of, mentioned. I think I'll just, I like to throw in privacy. So unfortunately, I will do that a lot with all of you because that's also my wheelhouse. We use it also in the health system, the AI, around some of the things that Shefali was talking about, which is related to sort of access. What are people doing in the system? So tying things together like, what is your role here? What are the things you normally do on a day-to-day basis? What are the systems that we say you should have access to? And then what are you doing? Does that make sense? And so sort of kind of like, you might call it an equivalent, this might be sort of a stretch, but like an equivalent of like internal threat hunting, like what are people actually doing and are they doing something wrong or something impermissible, something they shouldn't be doing?
Any statistics that you guys would be willing to share or experience in terms of how it's either accelerating detection or reducing fatigue on your team?
Yeah, I was gonna say I could answer that.
Yeah, again, I think there's lots that happens without getting into too much detail, but you all should be aware there are info stealer malware that is making a lot of rounds in the industry, right? It is impacting almost all the organizations, and many organizations actually sees an impact with that. Now, if you have an EDR solution, without naming a tool, implemented, there is a lot of sophistication with the help of AI models that is now built in where your EDR with intelligence can catch things early. Now, if that is happening, you're now moving from a reactive security to proactive security, right? So you're getting ready before things go wrong, so you can catch things early on. In some cases, even if something has gone wrong, you can control the damage early. So I would say, time is crucial, speed, consistency. So all of these parameters are areas which you're able to actually leverage with AI deployments.
Yeah, and I'll just say, we use AI for looking for phishing emails, right? We aggregate, we use AI to say, hey, you know what? If you see this type of email in 7,000 users' email boxes, take it out right away. So automating, right, with AI is key. So that saves. Now, one thing we're seeing is a transition in our SOC, right? The Security Operations Center. You used to have a level 1 triage analyst, right? Somebody newbie, associate comes in. You may not need that person anymore. AI can do that for us today, right? So now what does that mean? I don't need a level 1? No, it means maybe my level 1 can learn from what AI is doing. So not necessarily getting rid of the human in the loop, but also, and some organizations may get rid of level 1 altogether and just pay higher salaries for level 2s and level 3 SOC analysts. But level 1 is where the challenge is. Triaging is what AI is really good at right now, and I'm sure we'll see a lot more advancements in that area.
Yeah, I think one of the most important things about, you were asking about metrics or, what does that look like? I wouldn't say that I have statistics that I can give you, but what I can tell you is that the people, at least that work for me, they want to be able to do higher level work. I mean, everybody who wants to come in who might be new, they want to learn if they're new in their career, but eventually, people come in and doing the same thing day after day after day, for all of us, is draining. And so I think the most important thing that this can teach us all is that if AI can do well these easy tasks and you can free your team up to do more challenging things, not only are they doing important work for you, but they are also feeling good about the work they're doing because they're learning, they are actually thriving in their career as well and sort of not stagnating.
So just to kind of stay with that, taking the entry-level positions maybe or the lower-level starter positions, but are there any particular skill sets that you're looking for now that you might not have been a year or two ago, other than somebody who can perform at that level 2 or level 3 SOC analyst kind of thing?
Yeah, I mean, just quickly for me, I look for people who are eager to learn. Because like right now, you know, I don't know that on many security teams, security-focused teams, that you're going to find AI experts. That's not their background necessarily. So you need to have people who are interested in learning something and who are eager to learn something new. So that's something that I look for.
Yeah, I think one of the things, being a large university here in the heart of Chicago, right, is that we have so many different avenues of how we use AI, right? And so one of those is, how do we use AI to be innovative? We have students that create using AI, right? They will take it to market. We have an innovation center, and they will create it. We give them a business plan, a strategic plan. But the one thing that they are not quite aware of is security by design and privacy by design. So basically what AI is forcing us to do is say, okay, well, if you're going to go develop that new tool, did you put authentication on it? Is the data encrypted, right? Because with AI, we're going to need all these things enabled. And so a lot of the students are learning about security and privacy like they never did before. So I think there's a big learning moment here. So that's students. But then we have faculty that do a lot of research. Just, you know, Ron, you were talking about some of the research through research.net AI, right? So a lot of that type of information and research projects gone at the university in collaboration with so many other 3-letter agencies in the nation, right? Or anybody globally. And so we are always learning, you know, from a contractual perspective, when can you use AI and when you cannot use AI. So it's a little tricky, you know, dealing with that environment, but we kind of get around to putting security and privacy provisions into the contracts to understand exactly how AI can be used and how it cannot be used.
I think for me it is, it's like a couple of fundamental things, right? Like, I don't know if you've watched Barack Obama speak, but I want people who can solve things, not tell me 2 more problems. Can you tell me a way to do things, right? Like, a lot of people raise issues and concerns. I think that's a change that needs to come in. AI is here to stay, whether we like it or not. So that's a message that, and I'm like, when I look at my team, I'm looking at people. They could be junior as well, but if they are very eager to change and solve and try, they will get it. And others will be like us. So I think that's my first very basic foundation capability, competency that I look for. And the other thing is, you know, it's not just AI. It is AI and automation, guys. Whether you like it or not, AI has been used a lot. But for me, it is both of these things pairing together. So whoever has an automation mindset, I think those individuals will really succeed in the next whatever period we're talking about.
Almost forgot I had the mic. It's just so conversational. So I've heard, you know, you're talking about how you're using it to better track what people are doing, how they're using it. You know, you're using it to detect or automate things so that you can get to the level 2 analyst. Are there any other aspects or other areas of information security where you guys are employing AI?
Yeah, so besides monitoring, alerting, right, it's the actual remediation. That's the piece that's time consuming, right? We all have probably a SOC, we have an MDR, XDR, EDR. I can throw out all the different monitoring alerting tools, but who's going to go mitigate that? Or who's going to take that EOL, end of life server, down and rebuild it, right? So that's where I see a lot of retooling of the security folks, is that level 1 that maybe no longer triaging is using the AI to actually go mitigate, right? To actually do risk management. I don't think we spend a lot more time on risk management than we should have, right? And maybe some folks have a bigger budget and they can do that. So I see a transition happening, not only using AI for automation, so, you know, with phishing campaigns, right, we can do that. Besides that, I think we have AI learning, right? So there's something what we have was called an AI exchange. So 16 colleges, 50 other units that are out there, and they all are doing something with AI all over the place. So there's no way I can control that. But I can hear about it, I can understand it, I can then identify my risk, understand what I might need to do, who I need to work with. And so that's still a work in progress. Frank, I don't think we really have like a final, here's your laundry list of things. I think we're just kind of evolving as we go through this.
I think a couple of areas in which we have explored agentic, I think it's Gen AI mostly. The agentic is only coming in action. Incident management. So we all have to do record tracking. We do root cause analysis. You can use Gen AI to help. Like we are a Google shop. Sorry, Microsoft, but but we do use Gemini, tools to actually help us to actually do that. So, and that has helped our teams to not spend too many cycles. I have a small team, it's not big, we are 10,000 employees. I have like a 20-member team, which is decent size, but we have 18 countries to cater. So with all of this, if I'm able to use some Gen AI capabilities to do root cause analysis quicker, then when things go wrong, we can actually have a faster response. And there is also a thing that you can use some of the Gen AI capability, whether it's native in a tool or outside of it for your security questionnaires, right? We all still have to do a bunch of those things when we work for our clients. So there are those ways in which we are also trying to leverage internally.
I'll just quickly hook on that and then have Karen have you add to it. But at another panel, I heard somebody mention, you can't always remediate quickly, like you're saying, the issue, but you can use AI to identify mitigating controls you could put in place very quickly. So, Karen?
Yeah, I was just going to say, I think that's a fair statement about there's probably in security a lot more Gen AI going on than things like agentic AI. That being said, I think the troubling thing for me as I think about this is that the business is the other way around, which is that the business is much more focused on agentic AI. I mean, not that they don't use Gen AI, they do, but the innovation that's happening is way more on the other side. And so I think, unfortunately, sometimes in security, that's the catch-up that we're playing, and that's not always a good place to be, in my opinion.
All right, cool. Let's flip over to the dark side now. So what challenges are you seeing AI present as it relates to legacy systems or enterprise level types of systems? What are the challenges you're facing there?
Oh boy, me first. Okay, lots. Okay, so I think, starting with the easy stuff, challenges, is some of the stuff we've talked about already, at least, which is upskilling people. I mean, your security teams come to you with tons of knowledge. AI isn't always one of them. It's usually not one of the things that they know right off the bat. So, there's that piece. You have to be able to teach them what is going on. And I think, you had said something really poignant earlier, which is that, it's here to stay. I think a lot of security folks were like, oh, it's a passing thing, not that to knock on blockchain, but, I mean, like everyone thought blockchain was like a thing, and it's nothing like AI. And so it's just kind of like, it's here, and you're gonna have to get used to it, and you gotta learn it. So that's probably one thing. I think I sort of touched upon this with the agentic thing. I think that, in my mind, for security folks, is an utter game changer for us. I mean, it's one thing to think about privacy or data in Gen AI and what you put. Do you have regulated data? Should it go there? Is it contained in your environment? All the normal stuff that you think about all the time. And agentic AI adds this other layer where you've got business agents autonomously doing things that you may or may not know about initially, you may or may not have oversight over. There are going to be, at least if it's public facing, I can tell you, we all probably agree on this, although we've never talked about this, like attackers are going to beat on that thing all day long. They're going to automate it, and you have to figure out a way to do something about that. So I think those are sort of just the sheer scale is just mind-blowing, from a security perspective. That being said, I'm going to put in a little bit of a plug here for University of Chicago Medicine, which is that we are doing some really cool work with the university. So the health system, in conjunction with the University Computer Science Department, have started to do some IRB-approved research in the space of AI in healthcare. So things like, we talk a lot on panels about like this whole idea of scale and, creating phishing emails through AI that uses reconnaissance, and does that really game change the security? Spoiler alert, it does. But we are starting to do some research, real research around, like, if we do our, monthly phishing exercises, and the computer science department that we're doing the IRB protocol with uses AI to change up email language, are our users, when we're testing them, more apt to click? The answer is yes. But we're actually proving that out in research right now. So, I think a lot of the stuff we worry about in security, now that we're starting to research and actually see coming to fruition in ways that we now need to really take notice of.
Yeah, agentic AI is going to be amazing. Okay, so there's either you're going to love it or you're going to hate it. Okay, hate is a strong word. But I will say you're going to love it because it will make things easier. So let me explain and give you an example of how we're using agentic AI. We have a chatbot that goes and looks at all our KB articles. So we have an agentic AI that helps us with our help desk, right? User calls up and they have an issue. And they'll say, well, I don't know how to reset my password. Well, the chatbot will pull up the KB article on resetting your password. You don't have to have a help desk person do that, and that can be given to that person right away. They can look at the KB article. So non-sensitive areas, I can see a lot more agentic AI used to start, but I'm sure we'll get into, well, can you use PHI with agentic AI? Can you use PHI with AI and generative AI? Depends on what you have put in place, right? From a contractual perspective, who holds all of the liability, and how much you're comfortable, right? And so I think, Frank, when we talk about the dark side and what Karen alluded to is that, and Nitin, you said about the info stealers, right? They're there, they're out there. I can tell you, I have a chatbot that calls me every day between 7 and 8 p.m., right on the money, and is asking me to buy a loan. It comes from a different number every single time, but it's on between 7 and 8 p.m. Central Time, it calls me. There's Alan, John, Susan, Corey, Josh, just all sorts of names come through, but I can't stop it. So that's the problem with a chatbot. Now, I'll say on the research side that we do with agentic AI, we have a lot of internal students. We have our own AI sandbox environment where we have folks kind of play around with agentic AI, building out their own chatbots, what it can do. So there's pros and cons, depending on if you're on the receiving or creating end. It just depends.
I think there are a ton of experiments and some of the work that we are trying to do. My biggest fear is when we start working on client data. Like, is it approved by client? Is client giving a consent that we can actually run this experiment internally as well? Does the work that we are trying to do, will it actually get hosted and be available in the internet, right? Like, exposure management, data exfiltration, those are the concerns that we have. And, and as any organization, right, like many organizations are trialing, experimenting. You don't want innovation to be stopped or slowed down, but you need to have some level of guardrails that you set in place. Otherwise, things will really be bad, if I could say that.
What about governance structures? What have you all put in place? And I'm curious because whenever I ask this, it's always 50-50. Do you lock down AI for your lines of business or not? So you want to start?
I can give it a start. I think we've sort of, ThoughtWorks being a technology consulting company, wants to be recognized as the AI company. I cannot stop things. Like if I'm doing that, I'm not in my job, right? So we very well are allowing our developers, our engineering teams, our operation teams, everybody is trying. We have set guardrails for our teams. We cannot be everywhere. We do have 8,000 developers in the company, so most of them are really smart, so they know to do the right thing, but people can get things wrong. We do have governance forums where we have like a risk subcommittee, which meets on a regular basis, where we get the functional leaders, security, data protection, IT, legal, all in one room. virtually because we are in so many countries. So we do that on a regular cadence. And then we have a process called as a technology lifecycle management. So when somebody is trying to, try something new, and they will bring, it's like a gate process, right? So you come in and say, this is what I'm trying to do. We do some precursor checks and then give them the green light and they, hey, do it in a controlled environment, and those experiments would go. So yeah, I think it's few things that we are trying to do.
Yeah, with AI governance at a university such as UIC, it's very hard to govern, but you can exchange. So we have opted not to govern right now because we have, again, I talked about 16 colleges, 50 other units. If you have the ability to purchase something, you have the ability to take on that risk. I'm not going to take on that risk because you purchased something, right? Normally, CISOs are always under the gun like, well, it's your problem because we got hacked. No, it's the user behavior that gets us in trouble, right? So I put the risk back onto the user. And so we have something called AI exchange instead of AI governance. But don't get me wrong, there are decision makers in this AI exchange. So if there's something where, we know that AI could be used for a malicious purpose, then, we'll obviously say no and needs to go to a higher executive level decision making. So we do have a variety of different committees, councils, steering committees, risk management committees that we will take different issues to. So that's governance. But I will say, we don't want to stifle creation. We don't want to stifle innovation. We want students, faculty, and researchers to be able to bring AI to the university, but safely, securely, with data protection in mind, as well as safety. Safety is number one, right? Security and privacy, safety number one. So when we are able to open up the floodgates, basically, that's really what they are, that people will be more apt to share with you what they're doing. Because if you say, okay, we've got governance, they're going, well, should we tell them? Should we not tell them? It's going to be interesting. So we want people to be forthcoming, so that way, at least in my seat, I can understand what risk is coming to the university, and then I can mitigate it.
Yeah, we've chosen, I think, to probably govern pretty heavily, I would say. On the health system side, we hold every kind of data you could possibly imagine. I mean, aside from patient data and our own employee data, we've got this sort of bucket that I call consumer data, which is people who are not really patients and not really employees, or sort of like other people coming to us for all kinds of things. We have research data, we have financial data, because people obviously pay us for, their bills. I mean, we hold everything. And so, like Shefali, we don't necessarily want to stifle innovation. However, the regulatory burden is pretty heavy if something goes wrong. You're used to that as well, because finance too. So, we have a pretty strong governance steering committee that's actually led, we've chosen to lead it with myself in privacy and security and our chief analytics officer. So there are about 20 key stakeholders from the rest of the entire health system business. And then we have various subcommittees that report in. So, things like intake. So how do things come in? We have things that we develop internally, and we have things that we buy. So how do those things come into us? What is the contracting process? What are the risks around those things? Or we have things like inventory. How do we know what we even have? When people come and they say, I want to do this, do we have an inventory where we can point people back to and say, we probably already have something like that. Like, why are you trying to purchase something else or develop something else? So we do that kind of thing. Policies, which, probably most people have these days. We have a committee that does things like audit and monitoring, things like AI degradation. We have an education group, because you probably have realized this now, I'm super big on educating people. So, this whole idea of training your staff, not just my staff, the entire staff to be AI literate is a key concept for me, because it's not just my staff. The whole organization needs to understand what we're talking about here. So we've chosen to govern pretty heavily, but it mostly comes out of regulatory burden, I would say.
Okay. A few more topics I'd like to ask you guys, and then maybe we'll open it up for questions to the group. So let's shift over to third-party vendor and supply chain risk. how are you viewing that as it relates to EI? How are you trying, or AI rather, how are you trying to manage it? Karen, you want to
Yeah,
start?
that is such a tough one. So third-party risk management in the cybersecurity space exists regardless of AI. Like, it's a thing for all of us. I think AI adds a level of complexity to the mix. I think the things that are, that I try to think about, at least in my space, is really related to our patients and our employees mostly. And this probably comes from my social work background, just ultimately, which is like, I really worry about people. And so the concept of like third-party risk is really important to me because I need to really have an understanding of what the vendor is trying to do, or the third party is trying to do with our data. Like, I really see that as a really important concept for us at the health system level, which is, like, we need to be good stewards, like just data stewards of our patient data and our employee data. And, I want the third party to have the same respect and the same treatment of our data. And, sometimes there are things that, there's a few of us that look at third-party contracts on my team, not just me, but, we spend a lot of time trying to get to know our third parties and understanding what they want to do ultimately. And when something is too risky for us, we are not afraid to go back to our business partners and say, like, look, I don't know that this fits with our value system here, or I'm very worried, if we did a security risk assessment, that the third party's security posture is so terrible that, like, I can't even trust, like, doesn't mean they're going to have an incident, but that I just can't trust that they're, like, doing what I would want them to do. So those are the kinds of ways that I think about it.
Yeah, I think the biggest change for us is how we do our security risk assessments and privacy impact assessments, PIAs. So we have now started working with our DevSecOps developers, because if some vendor is going to bring AI, I want to know what model it is, what version of it is, right? I want to know will it train on my data? Will it send it somewhere else? Will it be sold to someone? So the who, what, where, when, why, and how, right? So we ask that for every single vendor that we would work with. And so we do the deeper dives in our security and privacy assessments. Besides that, we will also negotiate the contract. So that's something that I do in my role, is I will negotiate with the vendor to say if any breach does occur because of the AI. And if something happens where they change their product, right, that they come through back again and do another risk assessment with us, right? Just because we did it once doesn't mean that you can, as a vendor, go do what you wanted and then not have to circle back to your client, right, in that sense. So we want to make sure that whatever is in-house implemented is true to the state of what it is, reflective in the contracts. Because think about it, at a university we have FERPA, protecting student data. We have HIPAA. I have a hospital and outpatient clinics as well. I've got research, so research contracts have all sorts of stipulations on security and privacy. And then you stick AI on top of that, right? So all sorts of different data sets. And so we have to know where this data, who's going to use it, how will it be stored, how will it be transmitted, and what will that AI do? Because what are the two biggest problems with AI? Oversharing and data leakage, right? Those are the two biggest problems with AI. So how can I protect from oversharing, and how can I protect from data leaking out where it's not supposed to be?
I think they covered it. So it was very exhaustive. So.
Ditto, yeah. Karen, let me bring it back to you then. And so in terms of AI and the attack surface, you touched earlier on how bad actors are using AI to expand their phishing capability and more more target individuals in a better way. Are you seeing any emerging threats as it relates to threat actors attacking how you're using AI, like poisoning your models or things like that yet?
Yeah, so we haven't seen that in our organization. It's certainly something, all of the things that probably folks in this room know significantly more about than I do, for sure. So things like, prompt injects, data poison, like all that kind of poisoning of models, all that kind of stuff exists. So I hope we never see that, by the way, Frank. So I don't know that I want to even talk about that out loud. But, I think it's definitely a risk for any of us. It exists. It's something we should all be thinking about. I think what I think is interesting to me, at least, is that attackers can use AI in the same ways that we do, right? So they can go out, they can do reconnaissance on the internet, they can gather all kinds of information about people in, our organizations fast, easy, without, much to do on their side. And then they can use all of that information against you, through not only phishing campaigns, but in all kinds of ways. And so when you think about like how attackers work, they try to do things easy, fast, like, those kinds of ways. This just makes it incredibly easy for them because they talk about automation. I mean, they can just automate all these queries and get information and then automate phishing emails. And, we were talking about like things on the, website or, bots you have, like they're just going to automate everything. And so, they just move faster and more at scale than they ever have before. So that's the way I think about it, but.
Yeah, I think for us, the way we are, because we are a tech company, we're looking at, various strategies for, how do you, let's say you have a prompt design library, like how do you protect that? You are developing your own IP, how do you protect that? So it's all the standard, I would say, security controls, secure by design. Make sure you look at the enterprise architecture when you're developing things right at the start. So a lot of basics of security gets applied. We're not playing with our, like hosting our LLMs in-house yet. I think that point when it happens, I think it'll be a different challenge that we'll face. But for now, based on the usage that we have, the application that we are doing, I think it's mostly making sure the good practices, the best practices around security, which also overlays around data security, that should be applied. So both cyber and data security practices, if you're doing it well, you can at least get your baseline in control. So that's what we are trying to do now.
All right, last question, kind of a two-parter for each of you. Forward-looking here now. What's the biggest AI-driven risk enterprises are unprepared for, and what's the single best step an organization can take today to prepare for things?
Say that again. Say that again.
I'll do the first part. What's the biggest risk that companies are unprepared for that you guys see?
So it is always that nation-state actor, the malicious actor, who's going to come in and take down the entire university, right, where we can't get data when we need it, right? So that's like the ultimate nightmare. But I will say, I think it's not knowing how much AI is really being used at the university. So that's why I really truly believe in that AI exchange, because I need to know, but I don't want to be prescriptive in that, because right now we're building, we're creating, we're designing, we're trying to be innovative, we're trying to take it on. We have an executive directive to say, do something with AI in your job. So now that gives me the ability. We have an executive order from the new administration saying you need to do AI adoption as well. So more and more from a regulatory perspective is being put on us. But the other part of the risk here is from all of the regulations that are out there. So for example, one research contract could say, hey, dear researcher, you cannot use any AI. So wait, does that researcher then, can they not store their information in a cloud environment that's run by AI? Right, so it brings up some business operation decisions and quirkiness, I'll just say, that we're trying to work through. So there's that type of situation too.
Yeah, I would say generally the biggest risk, I would say, is when you don't know where your business has adopting AI. I think you have to have some sort of oversight over this. You're never going to know 100%, but you need to have a good handle on it is really the takeaway. And I think the second part of it was how do you solve for that maybe, which was that the
Well,
question?
Organizations today, what are the best steps that they could take to deal with that AI-driven threat?
Yeah. I mean, I think so. I'm just going to sort of reframe that if you don't mind. So, I think like the cyber and privacy teams have to be approachable. I mean, you just have to be. You can't be the type of person that people can't come to and tell you things, because then, like to Shafali's point, people will hide things from you, and that's terrible. So you need to be able to be a partner with the people in the business so that you can know what is happening so that you can best protect things. And I think maybe the best way, or at least the way that I've been thinking about this more recently, is that my team's partnership involves security, privacy, protection, all those things, but my partnership involves value driver, just like how do I help them innovate, drive value, make money for the business, and how does cyber and privacy translate that dollar for them? So, I spend a lot of time making the connection with my business peers about like my team does this, but I need you to see me like as a helpful financial driver for you.
Yeah, I think it is, the data exfiltration is still very big in my mind. So I think that's going to be really important. The use of AI the adversarial use of AI, that if that really happens, we're not seeing it yet, but it's coming. And if we are not prepared as a blue team or as a cyber defense team to handle it, I think it's going to hit us. So I think I really, really feel very nervous around it. And then I think the way we can address it is partnership, as we talked about, right? You have to be with your business. You cannot give them an answer saying, no, don't try this or don't experiment it. But if you are in the room when they are making decisions around this, and if you're with your legal team, your data protection team, your business stakeholders are including you, that means you're at least winning their hearts and minds, that they're like, hey, this group will actually help. So we should not go over them. There'll still be experiments, things that will happen. The full visibility nobody has. I think it's a big, North Star that we can all hope for. But I think the collaboration that we can do with business will help us fight this battle.
That's great. Thank you. One last thought, and then I'll open it up for any questions, is it just strikes me how much all of you have talked about data and protecting the data here in the last 15 minutes or so. And so in some ways it strikes me, it still goes back to the basics. What are your crown jewels? How do you protect them? But AI has really accelerated the threat against that and come up with unique ways to exfiltrate that data in different ways. So thanks to the panel. Wonderful input. Thank you. Any questions?
I'm very loud.
All right, go ahead.
I'm very loud. Well, first.
So even the streamers can listen to that.
Hi. First of all, I wanted to say thank you because I know you guys. I know at least some more than others. But I wanted to say, first of all, thank you because I have volunteered a lot this year in the cybersecurity community, and I've learned just how hard you guys work and how sometimes it's not valued. So I wanted to say that, first of all. My two questions really quick is, one, what keeps you up at night? And then the second thing is, what do you do on the other side so that you can, whatever is thrown at you, you can just, this is my thing that I do to push everything aside for 20 minutes, an hour, whatever you take, whatever time you take to release that, because this is hard work.
Yeah, I can take that. So what keeps me up at night is it's the client security events. If and when they happen, they are time sensitive. You could have one person make a mistake, and like you can get 99 things right, one thing wrong, you're still wrong. So that keeps me up in the night, because they could think things like that happen. So, but what actually I do, obviously I have to do individual things like, exercise, all of that. But what really helps me to handle it is my team. So I take a lot of pride in mentoring, in growing, in the team that I have. It's a global team. I'm the only one in Chicago. So all of my team, they're in different continents. So I am always on Zoom. I have a trip coming up to India in a couple of weeks' time. I'll be in Spain in a few months. So I travel a lot to make sure I have time with those individuals who are actually securing the enterprise. So I can't do it alone.
So what keeps me up at night? I'll say quantum. We're in the AI race right now. We're all going to be in it, whether we like it or not. You're just going to be dragged along with it. So let's just go, right? In that sense. So quantum is what keeps me up at night because I'm not well versed in it because I know that everything I put in place today can be undone in seconds, right? So I need to understand how do I come back and shove the door closed on that, right? So that it doesn't take down everything I've got in place. So quantum is so education, awareness, training, knowing the who, what, where, when, why, and how of quantum is how I deal with it.
Lots of things keep me up, Sophia. But I think that, the easiest way to answer this for me is that I wake up a lot in the middle of the night when I seem to have forgotten something that I needed to take care of during the day. And how do I deal with this? I've learned, so before I used to keep myself awake thinking like, I got to deal with this first thing when I wake up and then I can't get back to sleep. So now I actually take my phone out and I write myself a calendar note to do X at like 8 a.m. and then I can get back to sleep. So it's kind of lame, but.
Thank you so much.
Goes first.
Hi, Ron. It's good to see you. Hi, so I have a question. So I have a tech company that services the government at a federal level, and so obviously there's a lot of similar red tape as there is in the healthcare industry. The government has been very slow to adopt AI technologies. So what advice would you give to someone who is trying to advocate for more AI at the federal government level?
Yeah, I don't know that I have a magic thought for you, but it seems like this particular, not getting into politics, by the way, this particular administration wants to move AI forward. I don't know, they just published an AI executive order, which I think their idea behind this was to promote innovation. They also are super invested in, at least in the healthcare technology side. So I think my view is always that you should meet with people who are in like congressional staffers. I know that's probably a strange answer, but they are the people who have the direct, at least from my view, have the direct discussions with the people making policy or, who can do those kinds of things. The government is just slow, period. I mean, in security, if you think about like the HIPAA regulation, I mean, for goodness sake, this thing's been out for 30 years, hasn't even been changed. So, I mean, like, it doesn't even, the current health privacy tech, and even security is so old, it doesn't even like contemplate things like this. So I don't know that I have a great answer for you, but, what I will say is, meeting with the congressional staffers, if you can get their attention about things that are on your mind.
Okay, thank you.
I'll just say one thing real quick, is that, do you get audited at all?
So I've been in tech for about 10 plus years, and I just started this company recently. So no, I have not been audited yet, and I have been working with multiple congressional leaders in terms of pushing AI forward. And I know that ServiceNow just had, they just received a ton of funding for a huge government contract. So there is definitely some traction that's happening, but it's still very slow because obviously the government is slow.
Yeah, so I think, if you had been in business for a while, if you have audits, sometimes the audits will say, hey, are you using AI? And if you are, then they're going to want to know more information. But going back to what Karen said, there's an AI executive order out there, right? There's the AI adoption, there's the NIST AI framework to follow, right? So you can start out with the NIST AI framework as a beginning point, right, to say, you know what, hey, this is, being used by many other tech companies out there. So do we want to get left behind, or are we going to be in with the races, right? Possibly.
Thanks.
I think you've covered.
Oh.
Yeah, please.
Well, first of all, thank you for a very insightful discussion. My question was really about like the hacker's advantage. We talked about some of the entry vectors, like you talked about the phishing emails, you talked about the recon, right? But what about the payload, right? When you, for example, Shefali, you talked about detonating things in your sandbox. Are you starting to see like a hacker's advantage? Are you starting to see different types of more sophisticated variants of malware? Because we know that the hackers are also deploying some of the AI tools that, for instance, Ron talked about. Is there any evidence of that yet?
Yeah, there is. I think, again, a lot of sophistication on social engineering side. Info stealers making a lot of rounds across the globe. A lot of identity-based attacks that are happening, deep fakes. So we are seeing all of it, and we are trying to, we're trying to prevent. We are trying to navigate. In some cases, when they get through, we are able to fix it. But yes, we have seen the scale has changed. And I don't know whether it is really AI on the back end or not, but we are seeing a lot of sophistication in the attack side. And that's why I was saying, I think if we are not prepared on the defense side, I think we will, we'll actually lose the battle. So I don't know.
Yeah, I was just going to say that, it comes down to awareness and training. Right. So like with my DevSecOps folks, they're building codes, and if they see some anomalies, they're going to be on it like hot glue, right? But, training the user, the general user that's not familiar with security, not familiar with privacy, how do we train them to identify malicious, emails, as an example, right? The phishing emails. Is it one little character? So example, how many of you scan QR codes? So not anymore is some of the responses. I never scan a QR code. There's 60,000 characters. It just takes one to take your data. Just one characteristic, right? So there's things like that we want to educate our users on. And so it starts with the user behavior, trying to change that, helping them adopt the technology while it's happening, but putting guardrails around it, like that sandbox I talked about, right? Go do what you want to do, innovate over there, make the mistakes there, so you're not, impacting operations in that sense. But I think the other thing is, like in our roles as CISOs and privacy officers, is that we got to stay on top of nation state. So I am scrounging the internet every day for 2 hours, first thing in the morning. I won't tell you what time I wake up, but 2 hours I will spend just scrounging the internet for everything I can find possibly about scattered spider. That one specifically. Right? Because from that is what spawned all sorts of creativity for the malicious actors. So I'm always looking for that new variant that's out there.
I don't know that I have anything different yet.
One last question.
So I have a question around vulnerability management, because that's what I primarily do in my day-to-day. Do you see AI getting to the point where it's completely taking over that? I know it's automated in the sense of, tracking vulnerabilities when it comes to like servers and, end user computers and whatnot. However, do you see AI just completely taking that over? Because I know where I have an issue with is just looking for users itself. I don't know if that can be automated, right? Like looking for users to remediate what they need to remediate. But what would you say about that? I hope that made sense.
I'll just make one general statement, and then I'll pass it on. I do not, at least not currently, anyone has ever shown me anything that I've read or learned that says AI will take over, like, anyone's job completely, at least not in cyber or privacy, from my opinion. I think it will make things more efficient. Maybe there might be less people, but I think there's always going to need to be, to Shefali's point about human in the loop, there's always got to be somebody looking over it. I mean, I can't imagine, like, what if it was hallucinating, or I just don't think, like, you can just leave it to its own devices at any time soon, in my opinion, but that's just one person's opinion.
So if you look at tools like Wiz, and we use that for our cloud security, you have AI-enabled features. Rather than working on low, medium vulnerabilities, you put your focus on critical. So it will help you with prioritization. It will help you with pointing what needs to be remediated, so that either you can do it or you can get the actual tech organization to work on it. So it's going to help you do your job. Will it, eliminate? I don't think so. But we will. I think at the end we will need less staff, is what is being said across. So yeah.
I'll just add one more thing that what Nitin just said, right? Because you're going to use some kind of application, some tool to help you identify all the CVEs, right? And you're going to go through and go, oh my God, you know what? That server's got to be taken down because it's got 20 CVEs that hasn't been patched in such a long time. Who's going to make that call? You, the human, right? Because you're going to go talk to your unit contact and go, hey, did you know that you've got a server with 12 CVEs sitting out there since 2002 that you need to take care of? So, communication is where you really need the human in the loop.
Thank you.
Thank you, everybody. Thank you very much. Now I'm going to turn this back over to Ron, because there's actually 2 startups, and one of them is on quantum, so that fits right in with.
Thanks, Paul. Great conversation, great panel. Thanks to all the panelists for coming here, and thanks to Frank for moderating it. He had to leave, unfortunately. But we're going to switch over to our next presentation. So I've been trying to talk to Polsky for a while and inviting them over, and the timing was never right. So now we finally have, but we are still missing Shama, right? So probably next time we can have Shama over to talk to you. But we have Rahul here to talk to you more about Polsky, and then introduce the 2 startups that are here today. I haven't met them yet, but it'll be great to hear from them. One is about quantum, and the other one is about some AI in medical field, right? So they're doing some X-rays and studies and stuff. Would love to know more about it. Over to you, bro.
Get set up.
This is working?
Looks like it.
Okay. Let's take this away. So we have the whole space.
Let's see, are we working? Rid of that. There we go. Okay. Good evening, everybody. Great to meet you. My name is Rahul Singhal. I work at the University of Chicago Polsky Center. I'm going to introduce 2 of our startups. I will come and give a 10-minute kind of talk about what they do. But before that, let me just introduce myself. So I work at the Polsky Center. We are the Center for Entrepreneurship and Innovation at the University of Chicago, where our mission is to advance innovative ideas and technologies from the University of Chicago ecosystem to the world. Some information on University of Chicago. Some of you may know this, but I just want to talk about some of the stats. So we have over 18,000 students. This includes undergrads and graduate students. Over half of them are graduate students, whether they're in the business school or in the various engineering and grad programs that we have at the university, over 3,000 faculty, and almost 200,000 worldwide alumni. Another stat that everyone at UChicago likes to talk about is the Nobel laureate. I know somebody from Northwestern just won one recently, but 101 from UChicago. We even have a wall in our economics. It's not me. It's my university. Yes, at the Gleacher Center, you can see all their pictures. If anyone wants to see, all the Nobel laureates, come over to Gleacher. One of the unique things about University of Chicago and being in the Midwest is our affiliation with the national labs. We have 2 national labs that we are affiliated with, Oregon National Laboratory and Fermilab, as well as running a marine biological laboratory at Hyde Park campus. Another thing is, we have one of the top business schools in the country, so that's kind of where we sit at the Polsky Center. So within the Polsky Center, we really focus on 4 main pillars. The first one being advancing translational research. So that includes all of the faculty research and innovations that come, from our labs and from our university. We have a venture development team that is a team that was recently developed and spun up. These people come from industry that focus on commercializing some of this foundational, deep, tech research that is sitting in labs. So that's one of the things we do. Accelerating early stage ventures. I'll talk about our accelerator program that we run, which is where I sit. And then being kind of at the University of Chicago Business School, we really manage within our whole organization a lot of the entrepreneurial programming for the business school students and for grad students in general at the University of Chicago. Another unique thing, being in Hyde Park and being in the South Side is we have a community center called the Polsky Exchange. This has over 300 members from South Side and West Side communities, small businesses, small business development center, and we work with the government and we work with the businesses to kind of get them up and running and provide resources for them. All these member companies can apply. There's no fee for them, so we provide a lot of services for our local community as well. Some of the impact from the Polsky Center, I'll just kind of touch on some of them and explain in the next slide some of the companies and actually introduce some of the companies today. Over 650 companies have launched through the University of Chicago and through the Polsky Center. Over $1 billion has been raised by these companies, and we have over $8.9 billion, almost $9 billion in investments or exits that have come from companies that have spun out of University of Chicago. Yeah, we have licensing, so I'll skip over this so we can get to the startups, some of the cool, sexy stuff. If you look here on the right-hand side, these companies, some of these names you'll notice, Grubhub, Braintree, Simple Mills actually had a really good exit for us this year. These companies on the right-hand side have come out of our new venture challenge, which is going to be the business school competition. So all of the business school students participate. Well, they have the opportunity to participate in one of our flagship accelerator programs, and these companies have come out of that competition. On the left-hand side, so the other side, is kind of where I sit. That's going to be our focus on deep tech, which is a more recent thing for the university and for Polsky, about 4 years old. These are some of the companies that have come out of our deep tech accelerators. A lot of focus on quantum, MEMQ, actually QBraid, you guys are not on here, which I'm going to change. And then SlideFlow, you guys just graduated, so I'm going to put you on here as well. So these are some of the sectors and companies, quantum, health tech, basically deep tech, the way I like to see it, coming from a CS background and enterprise AI SaaS background before joining the Polsky Center. Basically, the way I define deep tech is anything but that. Another thing that we do, and we recently launched, is a deep tech fund. So this is an investment fund that's $25 million that is run separately from the university, but we work jointly with this VC firm, and their mandate is to focus on investing in majority UChicago affiliated companies, whether that's faculty, students, anyone that comes into our accelerator program. And what's unique about our accelerator program, which I'll get to, is you can become part of our ecosystem by applying and getting, being a part of our program. You do not need to have an affiliation, a prior affiliation with the University of Chicago to take part in our accelerator program. So that is a unique thing that we do. Not many other universities do that. So that is a unique point of the Polsky Center. If you ever come down to Hyde Park, we recently opened up a brand new incubator, built to spec, 300,000 square feet, 13 floors. It's going to be a big incubator space. We partnered with Portal Innovations, which runs a incubator here in the West Loop in downtown, and they're nationally recognized as well. They basically will manage our incubator space, whether it's wet lab space, dry labs, whatever a company need, even quantum suites. We have Blue Forest has come in and put in some equipment, and even IBM. And actually, this is an important thing. IBM, I know we're sitting in Microsoft right now, but IBM has invested in the University of Chicago, and we have a partnership with them. They are putting one of their flagship quantum computers in the lobby of Hyde Park Labs. So if you ever come to Hyde Park Labs and just walk around the building, you'll be able to see a quantum computer. The idea is to see it from the street level. So Alchemist Chicago, which I'll talk about now, which is our accelerator program, and then I'll introduce two of our startups to talk about what they do. This is a program that we recently launched this year. This is an accelerator program that we run at the University of Chicago that's focused on deep tech. Alchemist Accelerator, if nobody's aware of them, they are a Bay Area accelerator firm that has been around for over 10 years. They really specialize in deep tech, quantum and life science and biotech and health tech, and spinning companies up from there. We partnered with them because of some of the challenges being here in the Midwest and access to capital, and also some of the challenges with building a deep tech company. And I'll talk about some of the gaps and the challenges for those companies, and then why we partner with Alchemist in a second. To talk about the gaps, the deep tech gaps, essentially deep tech startups fail not from bad science or not novel innovation. They fail because they struggle to commercialize that technology. When you look at enterprise SaaS or a AI company, their funding required is very less compared to what you would need if you're building a deep tech or deep science company. Development cycles are much longer. They could be anywhere from 3 to 7 years as a development cycle to prove the technology and get to that level where you're commercially viable, versus traditional investors nowadays, and especially right now, are on accelerated timelines. So there's a gap there. And the complexity, of course, regulatory. We had a great panel talk about healthcare and from their background, and regulatory plays a big factor into some of the challenges and gaps here. Hence is why we looked at how do we enable our companies that come through our program to get more funding. One of the interesting facts about being in the Midwest is less than 1% of VC dollars is spent and is here. That's just the reality. We can't change that. Maybe in 10 years it'll get up to 10%, 15% like New York is right now, but right now it's still very nascent. Most of the money is in California, in the Bay Area, which is the reason we wanted to partner with a firm based in the Bay Area, and hence why we are combining the best of the deep tech here in the Midwest with the best in the Bay Area in all the capital. So that's really one of the reasons why we're doing that. Another fact I'll say, and I'll get into Alchemist Accelerator as well. I said it to a few folks here as well, but I found this very, very interesting. I grew up in the West Coast, but if you look at, and I also went to university in the West Coast, but if you look at within a 400-mile radius of the Metro of Chicago, and you take all of the universities, Michigan, Wisconsin, UIC, Northwestern, University of Chicago, go down to Purdue, Indiana, we train more than 40% of America's engineers. That's more than the West Coast and more than the East Coast. Where does this talent go, right? This talent needs to be here. They need to build here. So this is one of the reasons we have this program, is to let that talent build their companies here with the Midwestern resources that we have, and with our Midwestern culture, and bring the capital here to the Midwest. So Alchemist, some of the selling points of Alchemist and reasons why we partnered is you can look at some of the funds. These are the top tier funds in the world that companies that have gone through their programs have raised from. They were one of the first investors in Rigetti, which is a public company now in the quantum space. And they have accelerated over 750 startups in the deep tech space. One of the metrics that we're really excited about and really looking forward to seeing how that plays out with our cohort is over 50% of their startups that go through their cohort receive a term sheet at some point. And that is a really good statistic because power laws for startups, the reality is a lot of them will fail, but also it is not a guarantee that you will get a term sheet even after a demo day and going through an accelerator program. So we're very excited to see how that plays out for our companies that are building here in the Midwest. Brief overview of the program. This is our pilot year. We just kicked off and we had a phased approach. So we started with 30 companies that we kind of ran through a boot camp and a process to get them the best of UChicago's curriculum and our curriculum to get them ready for investment and into phase 2. Out of that, we've gone down to 10 companies that are going to be receiving a $550K investment safe. And this is going to be an Alchemist-led program. It's going to be hybrid with SF, Chicago, and virtual. So that we're very excited for. Actually, Sid, who will present from SlideFlow, is one of the companies that has come through our UChicago programs separately to the accelerator and took part in our inaugural cohort, and they actually got accepted this week into phase 2. So we're very excited for Sid to take part in that and see how he grows. In addition to Alchemist, one of the things we've been talking about and focused on for a long time since 2021 is Duality, which is focusing on quantum startups. If you guys are listening to the news in Chicago, a lot of investments and talk about quantum. The government is putting a lot of money, the state is putting a lot of money, the whole region is focusing a lot on quantum. In 2021, with these groups of logos you see down here, came together and said, how do we better enable the startup ecosystem in quantum in this region? And the answer was, let's start an accelerator program. It started off as a grant, a $50K grant, kind of as an economic development push to get companies into our region. And actually Qubate, who will talk today, was one of our inaugural cohort members that came out of that inaugural cohort in 2021 or 2022, if I'm not mistaken, Ricky, and now is building and raising money and is thriving here in Chicago. So Duality is a quantum startup accelerator that provides that focus on quantum. Finally, I'll end with this, and then we can get to the cool stuff, which is the companies and what they're building. Is we see ourselves at the Polsky Center as part of the broader ecosystem here in the Midwest. Within this flywheel, we sit kind of at the center, and we can kind of touch all of these different areas. With IQMP, the Illinois Quantum and Microelectronics Park, which just broke ground this summer. We're very excited for that. That's going to be on 93rd Street, back where the old U.S. Steel site used to be. Very close, about a 10-15 minute drive from Hyde Park, and our affiliation with our different laboratories here in the Midwest, and obviously with our Hyde Park labs, which I talked about, just being a brand new building that we opened up. We see kind of us at the center of the broader Midwestern ecosystem and bringing all of us together, regardless of your university. So with that, that's it for me. My name is Rahul Singhal. Feel free to reach out to me or chat with me. But I want to hand it off to our startups to talk. So maybe Ricky, I'll hand it over to you and Qubate first, and then Sid, I'll allow you to talk about SlideFlow. But thank you. I can take some questions while Ricky sets up. If there's any questions.
I was curious, where's that
can connect.
center? It was on the slide.
Yes, it's actually a brand new facility. We just we're opening up in Hyde Park, so it's on campus.
Oh, it's in campus?
Yeah, it's on campus. Yeah.
And there's one more question.
And then if you
Rahul, question.
yes.
Is the park
What's that? Yeah, IQMP.
Yeah, I know there was a lot of concern from the community members about that. Can you give me an update about that?
Yeah, absolutely. Yeah, the question was a lot of the concerns in the community, around the IQMP. Those are all very valid, concerns. One of the things that we do with Duality and within the University of Chicago ecosystem is we partner with a lot of different organizations that focus on addressing those challenges. And while those challenges do exist for those communities, one of the core pillars that David Ashalam has, which is one of our professors and the lead sponsor for the quantum initiatives here in the Midwest, is focused on workforce development. I said previously the stats of 40% of the engineers are trained here in the Midwest, but the reality is a lot of the quantum jobs of the future will not require an advanced degree. Right now, for the translational research and commercializing the research that comes out of the labs, they require these advanced degrees, but more and more as the ecosystem develops and it becomes more mature, a lot of the jobs that we will see will require maybe just an associate degree and technical training, and there are a lot of programs and organizations that have already started that process to train these folks and help the community kind of benefit from all of the changes and innovations that are coming to the region.
I know I heard something about there was concerns with something in the grounds in the previous plans up there, and also concerns about gentrification.
Absolutely. Well, I can't speak to that directly about the ground stuff, but gentrification, obviously those are all valid points, and I'm sure the policymakers and the politicians and everyone is thinking about that, and we're talking to the community members as well. Us being at University of Chicago, we are deeply rooted in our community. That is some of the programs and things that we do. So those are definitely, priority areas and top of mind for our stakeholders. Hope that answers your question. Happy to chat offline.
You stated that you have quantum computing, quantum computers up and running. So my question is, what's maximum qubit this quantum computer is doing?
Well, that's a good segue to Ricky. I think Ricky can answer that question. I'm not he will know what's there and what's also possible with the qubits that are there. So Ricky, I'll hand it over to you.
So thank you for your question. First and foremost, it really depends on which quantum computer you want to use. So you can vary from the ones with IonQ, for example. You can have the 28 qubit quantum computers, as well as other ones as well. So it really is kind of dependent on which quantum computers you want to use. And that's a good segue for what we do, which is we provide various quantum computers from our interface. And to put it lightly, you kind of mentioned just before, like, oh, what's the most qubits you can use? Well, there's a lot of quantum computers. All the ones you see here are a variation of a quantum computer that's available through qBraid. You see here, yeah. You're not sharing. Oh, okay. Yeah, I can. Sure. All right. So these are some of the variations that you can see. Some of them are trapped ion quantum computer, superconducting neutral atoms, so on and so forth. What's really great, though, is that a lot of these computers are very hard to use. And it's so hard to use that sometimes you go through many versions of various software packages to just start coding with them. That's where qBraid comes in, where we have a one-stop platform for quantum computing. And we have roughly 22,000 users. Some of our customers include the likes of AWS and Airbus, as well as various regional governments. And what's very interesting from our end is that from there, they're able to access 24 plus quantum devices, which I believe is one of the most, if not the most, available on any platform. How do we do that? Well, it's really easy. It's all available through your IDE, whether that's from VS Code or Jupyter, and it's also available through our platform by a cloud-based IDE of both versions. And of course, it's also connected to whatever cloud you're interested in using, such as AWS or Azure. So you can use your devices from Azure Quantum or AWS as well. So this is kind of what it looks like. This is an example of a Jupyter notebook, and then you can see some of the documentation available, as well as like the quantum devices, and you can basically run all of your quantum jobs through our SDK, which is a QBraid SDK. And yeah, it's a pretty slick platform, and we've been doing some cool stuff as well that I can speak about a little bit later as well. Of course, it's not comprehensive to just have an ID. A lot of people are like, oh, well, I don't know how to get started with quantum. Well, what do? Well, you have to build out some parts of the workforce development that's necessary as well as some other pipelines for tasks and applications in quantum chemistry and other areas of research. So on the top left, you see kind of a workforce development platform. We've white labeled that for various companies that are quantum hardware companies. So for them, they're like, hey, we just want to focus on quantum hardware. Can you guys do the software part? Can you like teach people about our software? We just offer that part of our platform. And then again, there's other interfaces as well that I can get into if you're more of a developer. All right. So I think Shefali just left, but that's okay. If you're a CISO, this was generated for you. And I use that word generated in with strong pretense. So first and foremost, I am not a quantum cryptography person, so I'm a quantum computing person. But I'll try my best to kind of talk about what this hype around post-quantum security is. Given the fact that we are talking about quantum security, let's give it a good example, right? Like, if you're coming at this from a cybersecurity perspective, it's like having a 0 day that you know about, but you don't really have the tools to actually fix or even implement the 0 day. So that tool that actually would implement, such as like decoding RSA encryption using Shor's algorithm, is like 30 years out. So you really don't have the tools to do and implement this 0 day if you're a hacker. And that's why people are like, oh, you have to do this thing called harvest now and decrypt later. What in the world is harvest now and decrypt later? That's a great question, right? So this is what all the fear-mongering has been happening with various governments is, oh, if you have data that is relevant to your country in 30 years' time and there's a bad actor that decides to steal it, they could potentially have access to a quantum computer and then decode them and then read about it, right? I would like strongly caveat that this is not something of a concern for most companies unless you just, as a very quick check, I don't know if you guys are CIOs, but how many of you guys have data that needs to be secured for the next 30 years? 1, 2, 3, 4, 5. All right, so we have people who have HIPAA, maybe PII, financial information and whatnot. Then it might be relevant for you to kind of learn about this. But again, what's interesting from what I've learned about 0 days, as well as toying around with Wireshark and a few of those more quantum or cybersecurity stuff is, if you know the 0 day, and then you can actually have a solution to it a lot faster. And that's actually what NIST has already done. So what that means is, yeah, so this is kind of the concept of it. You know, potentially you can have quantum computers decrypt it later. And let me kind of, before I jump into what this all means, let me kind of paint the picture. You would need like more than 1 million qubits to actually do this. We're roughly at around 120, 10 to the power of 2 is the order at which we are at. And so on top of that, the access to a quantum computer has been very much nationalized across various countries. So having some kind of bad actor steal your data and then have access to a quantum computer is very tricky unless they're also a national entity, such as the likes of China or Russia. And so whether those countries are really interested in hacking and developing quantum computer at the same time is kind of a tricky question to ask, because to be frank, China always posts these numbers about, oh, they've done a lot of investment into quantum, but it's really unclear if this actually is true and whether they'll build a fault-tolerant quantum computer as well. All right. So once again, if you have various important data that you need to store, then it's relevant for you to discuss these things within your team, but this is just very routine. It should be very routine cybersecurity hygiene for you and your cybersecurity team. This is some kind of quote here that discusses, that if your data outlives some of the cryptographic schemes, then your cryptographic schemes have already failed. But if you think about it, they always get updated year in, year out. You have your ISO, you have your SOC standards and stuff. So as long as you follow those, to be honest, I think you should be okay, is my understanding. So once again, kind of emphasizing, if you are a CIO, what your kind of like questions you should be asking yourself are. There you go. And then, so there's two kind of avenues from which you may have heard about quantum cybersecurity, which is PQC and QKD. Who has heard about PQC? One. I see like a small contingency here of people who are familiar with quantum security. Anyone else? Okay, we have one over here as well. Who has heard of QKD? Okay, so QKD, what's interesting, we have the longest network in the world, I believe, right in our backyard, developed by Toshiba, Microsoft, and the likes of MEMQ, who have been out of the Duality Accelerator program. And so PQC is like your software version, and QKD is your hardware. That's kind of the easiest way of thinking of it. So if your team needs QKD, you're probably like a data center. Like you need to actually make sure that everything is encrypted at the physical level. So yeah. So for post-quantum cryptography, this is just basically a software update, and I believe IBM worked on the last 4 algorithms that were approved by NIST to be part of the NIST standards, UCML, KEM, DSA, as well as a few others. And that was, I think, last August in 2024 where they decided upon these standards. And as we saw in the last quote there, it's not really something that's going to be, shall we say, foolproof for the next hundreds of years, right? Like security is something that you have to maintain all the time. So just keep up to date with what NIST says, and I'm sure that these algorithms will also mature as time goes. All right. And then the second one is quantum key distribution. So this is actually where you use optics. You can actually use some of the dark fiber that's available and then just make sure they're upgraded to use to handle quantum entanglements as well as other quantum phenomena to make sure that the distribution using the quantum key distribution actually works. And so this is perhaps if you are working at a data center, once again, this will be more relevant to you. So this is kind of a table for kind of making your decision as to like what you would be determining. And then I think as Shefali was mentioning, I don't know anything about quantum. Quantum is always kind of like, it's a little scary. Like it could be catastrophic if I'm not prepared for it. And when you hear quantum, people are like, oh man, this is going to be some sci-fi crazy thing. But really, you actually don't have to do much. From my understanding, you don't have to like upheave your security to like upgrade, because okay, we can skip that. It's actually already built into OpenSSL 3.5 plus, which was out, I believe, in 2025. So you already have some of the NIST standards out already. So you can actually just make sure that you do your regular checkups on your cybersecurity, make sure you're using the latest standards, and we would naturally expect some of these encryption standards to be available for cybersecurity teams to make sure that their standards are up to date for, everything from your APIs to whatever threat surface or interface you're working with. So, yeah. All right. So yeah, there you go. This is kind of my last slide. It's just kind of discussing parts of what we've discussed already. If you have any questions, let me know, and I will hand it over to the next startup. So, great.
Any questions, guys? Yeah, I always have some questions, Ricky.
Sure.
Yeah, so thanks. You mentioned that Open SSH 3.5 has the post-quantum algorithms. wasn't aware of that, but doesn't it require hardware accelerators, or you can run without hardware accelerators?
So it's an encryption it's an encryption algorithm. Now, I'm not very familiar with this, but if you can think about it, it's an open SSL, so you're given a public key and a ciphertext. You would send that to a server, and the server would encapsulate it, and then send back and establish a key between the client and the server. And this process does not require a quantum computer. This is just another algorithm that would be.
What I'm saying is the post-quantum stuff that
Sure,
you
yeah.
came up with, none of it requires, so there are 3 out. I think 4th is also approved.
Yeah, there's 4 and they're all approved. Yeah.
But, so, IBM was at the root of some of the stuff, so they have a special accelerator on AIX to be able to handle these algorithms because they're pretty performant intensive.
I'm not quite sure if we're talking about the same thing. I'm sure that there's some kind of other, IBM does a lot of quantum things, so I'm sure that they may be involving that.
Specific to NIST. That's okay.
Yeah, I would assume that this is just a standard encryption strategy that they've implemented. So
Simple.
yeah. Mhm.
Yes.
Like Apple has done this actually for iMessage, for example, already. Yeah.
Okay.
Mhm.
Good to know.
Yep. All right. Thank you.
Thanks.
All right, so I will talk a little bit about sort of the science behind what our company does, and we focus on using AI for developing next generation cancer biomarkers, and then close a little bit on what the startup that we spun out of our lab is called. Our startup is participating in the Alchemist program that Rahul was talking about. So to start, every cancer and every patient that is diagnosed with cancer requires a piece of tissue removed from their tumor. That tissue is looked at under a microscope, not too dissimilar from what you see here. And it's characterized by a type of physician called a pathologist who looks at patterns within that cancer and tells you things about it, whether it's high risk or what type of cancer it is. The issue with this is that the interpretation itself is subjective and experts aren't available everywhere, and this process isn't fully optimized and can really benefit from AI, and I'll talk about what that means. So currently, some centers essentially use high-resolution digital slide scanners to digitize these pathology biopsy slides into these ultra-high-resolution images that can be looked at digitally rather than under a traditional microscope. So those images look something like this. So this is an example of a lung cancer, and I'll show you a little bit more about this in a second. But to get a sense of the scale of this, this is a picture of Milan, or in Italy, and it shows you a sense of what that looks like from a zoomed-in version of a satellite image. As you zoom out of that image, you get a sense of just how far away we're looking at and how much information is captured in that image itself. So this gives you a sense of the scale of a satellite image, and that same amount of information is encoded within those biopsy images. For context, these images are approximately 4 to 5 to 6 gigabytes in size for a single image. So there's a ton of information encoded in it. As you might imagine, that's way too much information for a human to adequately interpret and take in one sort of sitting. This is where AI comes in. So we can leverage AI to develop computer vision-based biomarkers based on these high-resolution images. And we can do things that pathologists can do, and this is an example of that. So this is a real model with a real sort of attention heat map layered on it that tells you things about the cancer. These are things that humans can tell you today. It's an adenocarcinoma, it's well differentiated, this is a high-risk tumor. But perhaps more interestingly, we can actually see things about the tumor that we couldn't see with human eyes. You can actually predict the mutation status of that tumor without even running it through sequencing, and this was not known to be possible even 5 to 6 years ago. Perhaps even more interestingly, we can build models that are multimodal in nature. So you can fuse data modalities that are completely different, taking information from radiomics, from clinical information about demographics and their clinical characteristics, and fuse them together to develop a multimodal model that's even more accurate than a single mode alone. So ultimately, this is very promising. It can transform oncology care by improving clinical workflows, clinical trials, treatment planning, and even global health applications where there are areas across the world that do not have access to expert resources that can be easily replicated and perhaps superseded by AI models. But building these models itself is challenging. Slide scanners and the infrastructure to build and train and host reliable AI models and deploy them forward-facing is expensive. Predictions need to be timely, cost-effective, and streamlined. They need to fit within current existing workflows, and they can't create additional work. And data privacy concerns and security limit innovation and reduce data sharing. So I'll talk a little bit about what building a biomarker even means. It means taking a glass slide, applying some fancy AI model to it, and getting results at a broad scale. But what does that process look like? So we use our in-house platform called SlideFlow, and that's what our company, SlideFlow Labs, is sort of built on. It's an end-to-end deep learning platform that allows you to transform these high-resolution images, such as the one you're seeing on the screen, into an actionable biomarker that can tell you things of use for a patient. So again, now we're zooming back into the image, and you can get a sense, yet again, of this scale. So now we're looking at the cells all the way back from that sort of macro scale of the tissue, and this is what a specific image tile looks like. So you feed that image tile or a host of image tiles into an AI model, and you can do things such as classification, regression, segmentation, image translation. These are all different tasks that we might want to do for specific use cases. Classification might be trying to tell you what the diagnosis of a cancer is. Regression, we can tell you things about the hazard ratio or the likelihood of an event to occur. We can tell you things about segmentation. We can break the cells out of the image itself and tell you things about the cells that are of interest and of note that determine clinical decision making. And we can do image translation. So sometimes we want to see specific characteristics about an image that requires a specific protein stain, and we can do that virtually in silico. So starting with the data itself, and as everyone knows here, data purity, data cleaning is really 90% of the machine learning workflow across all domain applications. So we need to do tissue detection, remove background and white space. So you can see here that's a raw slide that even has a human's marking on the top of it, but we need to clean that out so that it's sort of the reliable solution on the bottom. We need to be able to remove artifacts such as those pen marks and focus issues. So here's an example of a slide that's completely out of focus, has a bunch of pen marks in it, but this is not usable in its raw form. So we do a lot of pre-processing to sort of correct for all of those things. Additionally, the images themselves, as I mentioned, are almost 5 to 6 to 7 gigabytes in size. So it's computationally intractable to do matrix multiplication on images and data of this scale. We have to actually tessellate the images into, patches or tiles and encode those tiles into feature vectors that do downstream tasks. And this is the way we ensure computational tractability when image sizes are this large up front. We do things such as stain normalization to improve stain consistency. So here you can see a bunch of different hospitals and centers are doing things differently, so the images look completely different. If you feed that to a downstream model, it induces sort of bias and batch effect that you need to correct for. But if you do normalization strategies, this is the same sort of slides that are then standardized on the bottom, leads to better model performance downstream. Compression and data storage is something that we're always thinking about. The models need to work quickly, reliably, without sort of compression or lossy performance. So we're kind of thinking about data efficient storage and post-processing pipelines consistently. To look a little bit more on the next step after you sort of handle the data, models. how do we do this? We can use pre-trained architectures such as DenseNet, ResNet, UNet. These are old school architectures that you can sort of fine tune and train models on. But we actually use different versions of this that I'll talk about a little bit more. So we focus now on a method called multiple instance learning, in which we sort of take advantage of two steps. There's the first stage, which is encoding, and this is using a large foundation model that's trained on sort of millions of slides to encode the features into a reliable feature vector that's extracted. And then a downstream classifier is then trained to a specific task. So you take these tiles that we talked about, you layer in a foundation model that, again, is a really large, robust model trained on, for, I don't know, 100 hours on a multiple A100 GPUs. And then you can sort of extract features of relevance on the other side of it and do things of relevance with those features. So here you're kind of just getting a sense of this bottom layer right here is a cancer slide, and these purple areas are areas that are of tumor, and these pink areas are sort of background tissue. You can see here that we're sort of encoding information according to where there's sort of hot areas and cold areas, and that sort of attention-based weighting is important for how we do things. So we take those features, then we train a classifier head called a multiple instance learning model, and we get a downstream model on the other side of it that can do things such as those things that we talked about, diagnostics, continuous prediction, so on and so forth. In terms of evaluation, we do a lot of sort of robust evaluation downstream to make sure that the models are reliable. We look at metrics such as standard things like AUROC, average precision, sensitivity, specificity, but we also look at the images themselves, and we use heat maps to sort of as a first crude pass of what's going on. So this is an example of our user interface where we're taking a look at the slides themselves, getting a sense of what is it paying attention to, what is it not paying attention to, is this consistent with known biology? And then we use advanced sort of synthetic explainability methods layered on top of this to teach back what the models are seeing. So we can have the model generate things on the other side in instances of what it would say is class 1 versus class 2, and show that to a human and say, does this make sense to you based off of what you know? And can you reverse engineer what the model's thinking? We have sort of class interpolation methods that allow us to synthetically interpolate a cancer from one type to another type while holding all sort of background stroma and tissue intact. This allows you to sort of assess one-to-one what are the features that are driving the differences in downstream model prediction. So this research is really the basis of my company, and some of my team is here with me. We're sort of developing an end-to-end deployment framework that allows people to not only build their own models, but reliably host and deploy them in hospital, biotech, and pharmaceutical settings. We can do this at extremely low cost with extremely low sort of infrastructure overhead that allows people to sort of get into the domain without needing to have extremely deep expertise or multi-year sort of build-out timelines. So we provide hospitals, biotechs, and pharmas with an end-to-end hardware, software, fully integrated machine learning platform to own, develop, and deploy their own pathology AI models for their own specific needs. So we focus again on this concept of biomarkers that work on things such as diagnosis, prediction, risk estimation, but currently biomarkers are largely limited by cost, time, and the biomarkers themselves not being sort of ideal. So what we do is we deploy our fully integrated hardware software system. So we have partnered with slide scanning hardware vendors that we're directly integrated with, where we can take those ultra high resolution images that we've talked about and build models that are reliable on top of it. It allows hospitals to sort of have a forward-facing framework that doesn't require any specimen sendouts. There's no costly infrastructure overhead. We handle all compute, all training, all data storage. And hospitals retain full data security and control. All of our sort of platforms are HIPAA compliant. And we don't take that data and do other things downstream of it, such as sort of train our own foundation models. So we've developed high-impact biomarkers that are ready to deploy forward-facing today, and our beachhead biomarkers in breast cancer, where we replace the standard of care test called Oncotype DX. So Oncotype DX is a test that's used in basically all early-stage breast cancer patients that tells a physician whether a patient might need chemotherapy after their surgery because their cancer is at high risk of recurring. Currently, that test costs around $4,000 a test. It takes a couple weeks to come back, and the payment schema, an insurer would then reimburse the vendor of this test, which in this case is Exact Sciences, for running the test. University of Chicago, where I'm a physician, sees about 500 to 600 cases for which they send this test out per year. So they essentially function as a revenue generation vehicle for Exact Sciences, where they generate about 2 to 2.5 million in gross annual revenue per year just off of this single test alone for Exact Sciences. And Exact Sciences grosses about 850 million per year on this single biomarker test. AI competitors sort of offer comparable solutions, saying that we can do this test with AI using computer vision on pathology images like we talked about. Instead of paying Exact Sciences, we can do it a little bit cheaper, we can do it a little bit faster, so they say, why don't you send us your assay? So we initially, when we were thinking about the company, we were thinking, oh, we can be another one of them, but we're doing something kind of fundamentally different. So we deploy the end-to-end framework in the actual user space itself, in the hospitals, in biotech companies, and pharmaceutical companies. In this case, if you're a hospital and you want to use this specific biomarker, the insurer would now reimburse you at that same sort of reimbursement rate. So for University of Chicago, if you simply onboarded our platform and you transitioned your current cases off of the send-out test to our in-house test, you'd immediately gross $2 to $2.5 million of revenue that you wouldn't see otherwise. So I won't really talk so much about our revenue model, but we have a lot of traction right now. We're deploying in University of Chicago, Northwestern, Rush, and Geisinger Cancer Center, which is part of the Kaiser family. We've partnered with multiple biopharma companies and hardware partners as well. My background, I'm a physician scientist at the University of Chicago. I've been doing research in the space for a long time, and our team is really interdisciplinary across medicine and machine learning. So we have pretty deep technical and clinical expertise at the same time, which allows us to sort of contextualize the goals of this work. And ultimately, I think our vision is to sort of function as what Illumina was sort of 15 years ago. For those of you that aren't familiar with it, Illumina is sort of a sequencing company, and their vision was, 15 years ago when genetic sequencing was first coming online, people would send the samples out to a vendor. That vendor, such as a company called Foundation One, would run a test and they'd give you a result. And that was really great. But Illumina came around and said, if everybody's ordering it, then everybody should have their own machine. So they deployed the Illumina HiSeq platform, and it's basically in all hospitals in the country today. So we sort of envision pathology AI and other AI for cancer omics in general as going down the same route. We're pretty excited to sort of be leading in the forefront of that. Thank you.
Awesome. Any questions? I think there's a question in the back. If you can.
H&E, IHC, we can do pretty much everything. So we have models, they're V1 models. H&E, so the question was, does it only work with H&E stains, which is that sort of pink and purple staining that we were seeing, or others as well? And it's cross-platform. So we focus a lot on H&E because it's sort of a ubiquitous data substrate, but we can work with anything. Yeah, we can absolutely do that. So we can do things such as these predictive tasks or sort of quantification tasks, and we're actually doing exactly what you're talking about right now. Please.
First of all, I thought I was smart, but you're like miles ahead of me. Second of all, how did you were showing us the solution. How did you find the problem?
Yeah, so it's a good question. I'm a doctor, so I sort of go back from what I see as problems in the hospital. I go back and try to build the solutions for them. So it's a little bit easier because I'm also the person that orders these tests on the other side. I think like from our group, it kind of helps to have that sort of interdisciplinary expertise. I think computer science is really awesome, and I am a computer scientist, but I think medicine is really awesome too. And there's not that many people that have this sort of overlap where you can identify the problem, you can build the solution, and then you can test the solution. So we have sort of a closed cycle, and I think that's what has really helped us sort of be successful thus far. We kind of have context on all ends. Thanks. I know, I agree. I agree with you.
I think we have a question in the back over there. Or
For like what's state of the art? It's a good question. So a lot of these, like, this is a pretty hot area of research, so people are publishing a lot. I think the issue that we were seeing is that there's a lot of cool papers. They don't generalize. They sort of work on some restricted subset of data, and they publish those results. There aren't that many people that are doing sort of decentralized forward-facing deployment. There actually isn't anyone else doing exactly what we're doing right now, where we're saying, we don't need you to send the stuff to us. We don't need a centralized processing process, and we can sort of handle all the noise and batch effect and compute against it. So, I mean, it kind of remains to be seen. We're still in early stages. We're, the methods work in research settings. We're doing these like validation studies across all of these hospitals. So if this works, it would really be first in class to say that you don't need to have any sort of centralized processing pipeline. We can just handle all sort of variants and changes and batch effects that each single site creates. In terms of like state of the art, our models, basically all these models that we're using are published papers that came out of University of Chicago research. So we only pick models that are, right at or, above what the best published models are, because we wouldn't just, go for something for the sake of it. Yeah, so, I am also like an employee at University of Chicago, so we sort of like fork, the research enterprise there acts as sort of an independent arm. It almost acts as an R&D arm for us, and then we pull IP out as needed. Yeah.
Good presentation.
Thank you.
I wanted to know, have you heard of seeing any other comparable work in models inside or outside?
Yeah, so pathology AI right now is one of the hottest areas in biotech. There's a ton of super highly capitalized companies coming out of Japan and in Europe that are doing this. In the US, there's multiple sort of like unicorn level companies at, $100 to $200 to $300 million valuations that are in the space. We focus on a little bit of a niche where we're focused on acting as a tooling platform for partners such as hospitals and biotechs and pharma companies to do this themselves. Otherwise, people are acting as, a centralized resource where you would partner with them, they'd take your data, they'd do things with it. It's sort of a different business model where that might get you scale, but it's not appealing to the customers that we sort of appeal to. So one advice we got when we were building the company is, you can be another fish amongst many, and that's certainly one way to approach it, but it isn't maybe the best way if you're later to the game. But if you are doing, a small niche that might be a smaller overall sort of market size, but you're doing it 98% better than the competition, that's the way to go. And that's kind of what we're focused on. So we're in a smaller niche, but we think we do this, 98, 99% better than the competition based off of our research. And, that's what we're laser focused on. So it's okay that there are other large companies doing things in the broader field at large. They just can't do what we do.
Any more questions before we end? I think there's a question over there, here. Let's go here first.
How do you compare,
Yeah, go ahead.
how do you compare it like Becton Dickinson?
With which?
Becton Dickinson?
Becton Dickinson's, I don't know.
Doing this kind of stuff without AI?
Without AI?
Since like 1980s.
Yeah, like standardized sort of like cell counting and things of that sort. Oh, yeah. So, we can essentially pretty easily replicate state-of-the-art with any classical methods today. That's not really, it's frankly not an area of research we've been invested heavily into. So there's two main arms in Path AI today. One is automation. So can we replicate what we can already do? And can we replicate this faster and cheaper? So we know we can do that because we've proved out in, 100 papers so far that simply replicating a human's interpretation or replicating sort of a standard classical machine assay is really easy to do. What we're more interested in is sort of prognostic and predictive tasks. So, these are things that humans can't do. So can I tell you you're at a high risk of your cancer coming back within 5 years? when a pathologist looks at your slide, they can't tell you that. They can only say that this looks like a gnarly cancer, it doesn't seem good. They can't tell you the specific risk that your likelihood of coming back. Or can I tell you before you have cancer and you have a precancerous lesion that it might become cancer? That's also something that you can't do as a human, because like I was saying, the images have so much information embedded in them, it's not possible for your like mind to sort of comprehend all of that. So that's what we can sort of do better. So we're focused a lot on these like predictive and prognostic tasks rather than sort of classification or just sort of counting tasks. Correct. So we're like a technology, we're a platform company. So we essentially give you all the tools, and we're building, my engineering team over here is building like user interface based tools. So right now we do this all in Python, and it requires a lot of like knowledge of machine learning and how data science works and how Python works. But you know, what we're finding is that there's a ton of domain experts that are doctors or researchers that don't know how to code. So how do we get them into the ecosystem? So what we're actually focused on is building sort of user interface based tools with agents in the background that can guide you through the minutia. But you can get to sort of a reliable V1, V2 model that works for whatever task you specifically are interested in as a domain expert in, I don't know, in brain cancer. You have a very specific question you want to ask. We can get you the tools to do that, and you can do it yourself even if you don't know how to code. So that's sort of our vision. We have sort of a stepwise process of doing this. We focus on these diagnostics as sort of a foot in the door. We can say, offload your external diagnostics and put it on our platform, and you can generate a little bit of revenue. The stage 2 is we have a bunch of different biomarkers. You can increase your revenue just by using the ones my team has built. Stage 3 is really, now we want to give you the tools to build your own. You don't need a code, you don't need to know anything about machine learning, but we can still get you there. And that's sort of how we like democratize the development of these things, because there's essentially millions of models that can be built. It just depends on what data you have and what questions you want to ask.
My question was more on the last part you just mentioned, the data. Would you be able to share a little bit more on what is the source for your data and how you're vetting it?
Yeah, so a lot of our data comes from either the University of Chicago. We have like pretty deep partnerships with the National Cancer Institute. So when there's like these large clinical trials, generally they have standardized data collection procedures where biopsy samples are taken and the physical glass slides are kept, or they're digitized and those images are stored. And as like a researcher at University of Chicago, we get access to all of that stuff. So my company sort of licenses IP as needed. So there's a lot of research ongoing at U Chicago. If it's appealing, if it seems commercially attractive, then we say, and like, okay, we'll go ahead and negotiate that out. And then we use that for sort of downstream purposes. From like a data privacy issue stuff, we're like all HIPAA compliant and everything, so all the patient data is protected. But we don't actually take the data and do things other than what we tell them we're going to do with it. So we're not like a data aggregation play or a big data play, and that makes us appealing for partners like the University of Chicago, because they don't want to give their data up since it drives their research enterprise. Absolutely, yeah. Like more philosophically, you're kind of getting at, like, I guess I'm not.
Repeat the question. Like for instance, it just makes me think about as a patient, if my doctor makes diagnosis, it's not good, it doesn't sound good. It might depend on how much they're up on the latest research.
I mean, that's certainly true.
Again, yeah.
That's certainly true. I think that's just sort of a reality of the medical system. Some physicians might be way more up to date with sort of research guidelines and all of this stuff. It's constantly evolving, so it is hard to keep up. I would say, at academic medical centers at University of Chicago, there's like a concerted effort to keep doing that. So when a new paper comes out, it gets kind of propagated throughout, and that goes. But if you're in a small community hospital and you're the only practitioner, you kind of have to do that on your own. So you need to come up with systems to do it. But unfortunately, there's no great solution to that.
I had a doctor to tell me that once. It was very scary.
Yeah. All right, thank you.
Any other questions, guys, before we end? I have a couple of questions for you, actually.
Oh, yes.
So regarding the data, so do they de-identify the data before they give it to you, or how are you dealing with that?
Yeah, it's all de-identified.
It's all de-identified, okay. And how are you getting those images, those high-resolution images? Is that from an electron microscope or some other device? Or?
There are these like ultra high resolution digital slide scanners. It was on, I think, the second slide in the deck, but these are, like you can have batch scale slide scanners that can do sort of 500 slides, and it takes an hour for them to kind of comb through and slide through it. We partnered with this company called Grundium, which is a Finnish company that provides sort of a small, portable, laptop-sized digital microscope that you can sort of stick your slide on. Within 2 minutes, it'll scan it, just combs through, takes a picture of it. That image is then sort of saved and sent to the cloud, and then ports over to our sort of cloud platform from there, and then we handle the rest and all the post-processing like I kind of talked about.
So you send the slides out with the specimens, or?
It depends. It kind of depends on the project. So, when we're doing research with the University of Chicago, we have the physical slides and we go ahead and scan them ourselves. But other times when you're working with these clinical trials and everything, they're already digitized. So we handle, images from other slide scanners as well. So it depends on if we need to capture the image or if it's already digital.
Yeah, sounds good. That's all I had.
Thank you.
Anyone else? I think there's one more question. Oh, okay. So I think there's no more questions. Great presentation. Thanks so much. Thank you. Okay, and Sophie, right? Sophie has announcement or some comments to make. Okay, go ahead.
Hi, everybody. I just wanted to share really quick that that I got a scholarship to attend RSA 2026 in March, but this year, unfortunately, I wasn't working, so I'm proactively raising funds for what